Okay, this is the last lesson in this unit. We're going to be discussing piecewise-defined functions. So when you're finished with this lesson, you're going to be able to graph and write piecewise-defined functions. So first of all, we have a warm-up. Pause the video and work these problems and then come back in a little bit and check your answers. Well, as you see, this one crosses the y-axis at a positive 8, and it has a negative slope of 1/4. So down 1/4. This one crosses the y-axis at 2, and it goes up 4/3. Now, it looks a little tricky, but notice that the scale is by 2 on this. A piecewise defined function is a function that is written using two or more expressions. So you'll need to make notes on steps to graph a piecewise defined function. First of all, you have to graph each expression separately. Now, to determine where to begin each part of the graph, choose the value indicated in the expression. We'll look at that more closely to see what that means. And the starting point is a dot if the point is included in the graph, and is a circle if the point is not included in the graph. So you're used to that with inequalities, right? So first of all, we're going to graph a piecewise defined function. You might want to write this down in your notes to make it easy for you to follow along. The function is x minus 1 if x is less than or equal to 3, and -1 if x is greater than 3. And then we're also to identify the domain and range of the function. So first of all, we're going to graph the linear function f of x is equal to x minus 1, because that's the first function we're given, for x is less than or equal to 3. So let's choose 3. When I was talking about the indicated value, that's the indicated value, 3. Now, because it's or equal to, we're going to put a closed circle at 3. Now, when we put a 3 in for x, what's 3 minus 1? That's how we get that 2. So see how easy it is? We've already done all these things before. Now we're just giving it a little more punch. So we've got a closed circle at 3, and at 3, 2, I'm sorry. 1, 2, 3, 2, and then we'll continue using values that are greater than 3. If we choose values for greater than 3, we'll see where we end up going. Okay, so we know that the other constant function is -1. So x is greater than 3. X is going to be greater than 3. And it's going to be at a -1 because it's constant. So we have an open circle because it's not greater than or equal to. 3 does not satisfy the inequality. And so we begin with a 3, -1, and anything greater than 3 is going to be a -1. So anything less than 3, we'll use the first function to evaluate it. Any value for x that's greater than 3, we're going to use the constant function to evaluate it. So the function is defined for all values of x. So let's look at our values of x. Is there anything that's being excluded here? No, there isn't. Even 3 is included because it's part of this function. So the domain is all real numbers. Now let's look at the range. Well, the range is limited. The highest the range goes is 2, right? But it keeps on going down. So our range is f of x such that f of x is less than or equal to 2. Now we're to write the piecewise defined function shown in the graph. Thank goodness the graph is also shown again here, so we can start picking up on that. So we're going to examine and write a function for each portion of the graph. So if you just break it down one bit at a time, it makes it easier. The left portion of the graph is the graph of x, of f of x is equal to x minus 4. How do we know that? Well, it crosses the y-axis at a -4, right? So if x is 0, y is -4. There is a circle at to negative 2, it's an open circle. So we know that we have just a less than symbol. It's less than 2, right? X is less than 2. Let's look at the other one, the right portion of the graph. We've got a closed sign. So there is a constant function at 1, right? 2, 1. So when x is 2, y, it doesn't matter what x is. Y is always positive 1. So we've got a constant function, f of x is equal to 1. So there's a dot at 2, 1. And the constant function is defined as x such that x is greater than or equal to 2. So our answer, we're going to use x minus 4 if x is less than 2. We're going to use 1 if x is greater than or equal to 2. Very good. You're ready to begin your assignment today.